Welcome to the Boomer Technician. Today, we're in the shop and we're working on the inside of the car. I recently replaced the dash lights, the original incandescents, with some LED bulbs, and they work really well. Well, they shine really brightly, but they don't dim very well. And I'm not sure if it's a LED bulb problem or a circuit problem. So, what we're going to do is we're going to take some electrical measurements and then we're going to apply some Ohm's law and come to a few conclusions as to just exactly what's going on. So let's cut over to our voltmeter and see what's happening. Okay, with the voltmeter operating, we're going to turn the lights on and then we're going to dim them. And as you can see, as we turn the knob to dim, the voltmeter doesn't change a whole lot. We should see it dropping from 13, 12 and a half volts down to about 7 or even 6 volts. And that would tell us the circuit's dimming, but it's not doing that. And so the question then becomes why? So let's go ahead and apply a little Ohm's law, build a circuit diagram, see how it works, and see what's supposed to be happening versus what we're seeing here on the voltmeter. Now that we've measured the circuit and we know we're not getting enough voltage drop to dim the bulbs, let's take a look at the circuit design and figure out what the problem is. It's a pretty simple circuit. There's a fuse that feeds 12 volts to the headlight switch, and then there's two components in the headlight switch. There's a switch that energizes the circuit, and then there's also a variable resistor or a dimmer circuit that reduces the voltage to the bulbs as you turn the knob. And then we've got 6 bulbs. We've got 5 bulbs in the gauge assembly and 1 in the heater panel, and they all go to ground. And so that's the whole circuit from power to ground. When we're in the dimmest position, the dimmer circuit is adding about 7 ohms of resistance before it gets to the bulbs themselves. And that 7 ohms of resistance should cause the voltage going to the bulbs to drop to about 6 volts. And that's what dims the lights. So we need to figure out why we're seeing 10 volts there when we should be seeing 6 volts. And to do that, we're going to look at the resistance of the bulbs. And because they're parallel bulbs, we need to do a calculation to figure out the resistance based on the resistance of each bulb. And it's a pretty simple equation. You can see it right here. Or we could just go online and find an application that will give us the value when we just plug in the resistance of each bulb. So let's go ahead and do that. For each bulb, we're at about 46 ohms. So in this calculator, we're going to say there's 6 loads or 6 bulbs, and each one's 46. And then we hit calculate, and it tells us the circuit resistance of those 6 bulbs is roughly 7.7 ohms. Now I know the resistance at the max dim of the headlight switch is about 7.5 ohms. So that makes sense because we've got equal resistance on the side of the bulbs and the same resistance on the side of the dimmer switch. We know that the voltage is about equally divided one side to the other. So we should see 6 volts on the power lead running from the dimmer switch to the bulbs in the dimmest position. And with the LED bulbs, we don't see that. We see about 10, maybe 10 and a half volts. So I'm guessing the resistance for the LED bulbs is different. When I calculated the resistance of the LED bulbs, I came up with 210 ohms each. Now that's quite a bit different than the other bulbs, which were only 46 ohms. So let's stick that into this app and see what we end up with for a circuit resistance. So we're now going to put 210 ohms into all of the resistors except the last one because the heater control panel still has the standard bulb in it. I only put LEDs into the gauge assembly. And when we hit calculate, we end up with 22 ohms, about 3 times the factory bulb resistance. So now that we've determined the resistances of the 2 different bulbs, we've identified the problem. Because the LEDs have so much more resistance on the bulb side of the circuit's out of balance. With the original bulbs, when we had the dimmer set to full dim, the dimmer side was about 7.5 ohms and the bulb side was about 7.5 ohms. Now that we have 22 ohms on the bulb side, the system's out of balance and we can't bring the voltage down to the point where it starts dimming the LEDs. So to fix this, we need to reduce the resistance of the bulb circuit. And oddly enough, in a parallel circuit, to reduce the resistance, you add another path with an additional resistor. So we're going to take a look at the application and we're going to figure out how much resistance to add to the seventh path. So in the application, we're now looking at 7 different resistances. We've got the 6 bulb resistances, and then we're going to add a 7th resistance, 7.5 ohms. We're going to do that because I have a component with a resistance of 7.5 ohms that we can easily add to this circuit. And if we hit calculate, we get down to 5.5 ohms. So that's a lower value than the factory circuit. So we should be able to get the dimmer function to work again. We should be able to dim all the way down to 6 volts in the circuit. Now before we continue, we also need to do a check and see if this 5.5 ohms in this bulb circuit is going to blow the dimmer circuit fuse, because it's only a 4 amp fuse. To figure this out, we're going to take a look at the circuit, and when the dimmer is on full brightness, it's got very little resistance. It's probably got a 0.1 ohm resistance. So we got 0.1 ohm resistance feeding into the bulb circuit, which is 5.5 ohms. So that's a total of 5.6 ohms. If we use Ohm's law and divide that into 13 volts, the circuit voltage of the car, we end up with about 2.3 or 2.4 amps, which is perfect because that's well below the 4 amp fuse in the circuit. And we should be able to brighten and dim the circuit without worrying about blowing the fuse. Hopefully all that math made sense to you. The bottom line is, in order to get the LEDs to dim, we need to drop the circuit voltage, and to do that, we have to add another resistance in parallel, and that value of that resistance needs to be about 7.5 ohms. And coincidentally, your standard Mustang 2 headlight switch has an adjustable dimmer circuit that can be adjusted to 7.5 ohms. So that's a double win. Not only can we get exactly the value we want on the switch, but it's also a switch designed to work in the car, so we know it's going to work just fine. And there we have it, proof of concept. So with that, we'll get the Soul Survivor back on the road with a working dimmer switch and gauge lights that brighten and darken. And as you know, wherever you go, there you are. In a headlight dimmer switch circuit. Whew. Just as a side note, before we go out to the garage, I did want to make sure we're not going to blow the fuse. So I made yeah, you're a lot of help.